Divide polynomial functions. So we're going to talk about long division. If we have x minus 3 and we want to divide 3x squared minus 4x minus 15 by x minus 3. So what you want to divide with, the numerator goes under the radical, the denominator goes outside. And how I like to think about it is, what do I have to times x by to get 3x squared? Well, I have to times it by 3x. Multiplying through, I get 3x squared minus 9x. And now you subtract off the row, or switch the signs. These two front cancel. Negative 4 plus 9 gives me 5x, and I drop down my next term. Then I ask myself, same process, what do I have to times x by to get 5x? Well, I have to times it by 5. Timesing through to each thing, I get 5 times x, 5x, 5 times negative 3, minus 15, subtract off the row, and in this case, in both cancel, so 3x plus 5 is what I get when I divide 3x squared minus 4x minus 15 by x minus 3. What if I want to divide 2x cubed minus 12x minus 10 by x minus 4? Here's something to note. There's an x cubed to an x to the first term. There's no x squared term. So we're actually going to rewrite this. We're going to say plus 0x squared minus 12x minus 10 all over x minus 4. Whenever we have powers of x that aren't represented, put plus 0 whatever that power is. So then I ask myself, well, what do I have to times x by to get 2x cubed? I have to times it by 2x squared. Multiplying through, so 2x squared times x, 2x cubed, 2x squared times 4, negative 8x squared, and this is the reason we put the 0 in. It's more of a placeholder than anything else. Subtract off the row, or switch the signs. They cancel. 0 plus 8, 8x squared, drop down my next term. What do I have to times x by to get 8x squared? I have to times it by 8x. So I get 8x squared minus 32x. Subtract off the row. They cancel. These two combine to make 20x. And I drop down my next term. What do I have to times x by to get 20x? 20. Timesing through, I get 20x minus 80. Subtract off the row. This leaves me with 70. So this is a remainder. Here's how we do remainders. We say, because x doesn't go into 70, we can't times x by something to get this. That's how we know it's a remainder. We say 70 over what we divided by x minus 4. So this would be our answer. Say I want to divide 2x to the 4th plus 8x cubed plus 2x squared minus 5x minus 3 by 2x squared minus 2. What do I have to times 2x squared by to get 2x to the 4th? X squared. Multiplying through, I get 2x to the 4th minus 2x squared. Subtract off the row. Dropping down this term, I get 8x cubed plus 4x squared. What do I have to times 2x squared by to get 8x cubed? 4x. Multiplying through, I get 8x cubed minus 8x. So that goes with this column because it's not an x squared, it's an 8x. So minus 8x. So we're going to drop down this term. Subtract off the row. These cancel. 4x squared plus 3x minus 3. What do I have to times 2x squared by to get 4x squared? A 2. 4x squared minus 4. Subtract off the row. So I get 3x plus 1. We can't times 2x squared by to get 3x. There's nothing we can times it by to get 3x. So that's our remainder. So we say 3x plus 1 over 2x squared minus 2. Say I wanted to divide 6m cubed minus 8m squared minus 5m minus 6 divided by 3m minus 6. So what are times 3m by to get 6m cubed? 2m squared, multiplying through, subtract off the row, what do I have to times 3m by to get 4m squared? Well, here's kind of a trick. There's not a whole number, right? So if I want to make this a 1, I'm going to times it by 1/3. So I'm going to put a 3 in the denominator. If I want to make that 1 now be a 4, I get a 4 in the numerator. So 4/3 times 3 would give you 4. And to get the m to an m squared, we need to times by an m. So the trick is, in the denominator, put the number you want to get down to become a 1. Then in the numerator, put the number you want it to become. So to take 3 to 4, we divide by 3, get it to be a 1, times by 4, it now becomes a 4. So 4/3 times 3 is 4m squared. 4/3 times 6 is minus 8m. Subtract off the row. They cancel. We get 3m. Drop down our next term. 3m minus 6 to get 3m minus 6 is just plus 1. So we get 3m minus 6, subtract off the row, and everything cancels. We have no remainder in this case. The interesting thing to note was that we had spots where we actually have to put a fraction in, not whole numbers. They don't always work out to be whole numbers. Let's say we were given f of x is equal to 8x squared plus 2x minus 3, and g of x is equal to 2x minus 1. And we want to find f divided by g of x. Well, remember this from the algebra of functions unit in videos. So if I want f divided by g, I take the f function divided by the g function. We could either leave it like this or see if it actually simplifies. Let's see if it simplifies. So we have 8x squared plus 2x minus 3 divided by 2x minus 1. To get a 2x to become 8x squared, we times by 4x. So we get 8x squared minus 4x, subtract off the row. So we get 6x, drop down the next term. 2x, to get 6x, we have to times by 3. So we get 6x minus 3, subtract off the row, we get no remainder. So this divided by this is the same thing as 4x plus 3. Well, now, if I want to evaluate, say I want to evaluate what f divided by g of 8 is, isn't it easier to stick it in this than this? Sometimes by doing long division and simplifying, it creates an easier function we can then plug things into. So I can say 4 times 8 plus 3 is 35, rather than putting an 8 here, an 8 here, an 8 here, and having to do it in multiple spots. And if I want to keep plugging in numbers, you can see how quickly it could become a really long process. Another thing to note is in our domain, even if we simplify, we have to look at values that would make this 0, which would be x equals 1/2. So the one number we can't have is x equal to 1/2, because that would make us divide by 0 in our original composition or combining of these functions.